right, this is homework 3, part D. Derive expression relating torque, angular velocity, gap width D, height and radius of a Covet viscometer to the absolute viscosity of a fluid with given mu. We can draw a cylindrical tank to put our viscometer in. There's that, and then we'll give that a symbol of angular velocity. We can also label this as our height h. This distance between the viscometer and the edge of the tank is going to be labeled as d. And then we need a radius of r. So we can begin the next part of the problem by writing some equations. We know that our velocity times our sigma is equal to the stress, and we also know that velocity is angular velocity times your radius. Make it lowercase just to keep consistent. And then we also know that T is equal to force by radius. And we also know T equals force over area. So if we solve for F here, we can see that F is equal to torque over radius, and then we can substitute this F into here, and we will write our area as being 2 pi r times h. So it'll be this times this, and then we can plug our area into here and get an equation for our torque, which is going to be equal to and I keep switching back and forth between capital and not, but they're both radius. So we can simplify this to be okay. And then we will, we know that our sigma is equal to velocity over distance, and substituting this into here and then this in here, we can write that our torque is that this is going to be equal to this times this, which is WR over D. And because we are asked to relate these variables to this, we will solve our equation for our viscosity, and that will look like torque times gap width divided by 2 pi r, and then this will be times this, so cubed times h times angular velocity is equal to our absolute viscosity of the fluid for this question. So with that, I will box in our equation, and that is all for this problem.